Good evening, students. Welcome to this video session. I remain Samuel Chukwuemeka, Samdom for Peace. In this video session, we shall continue our discussion on how to use the calculator on your computer to calculate the mathematics of finance. So let's get on my website, samuelchukwuemeka.com. Click on my picture to enter the site. Click on mathematics. Go to finite math under the notes. So we shall look at some solved problems on annuities. Please, before you view this video, it is recommended that you start with investments for retirement, part 1. We discussed what annuities are all about. We discussed what is an ordinary annuity, what is an annuity due. Okay, we discussed that in this video, in this note, and in the videos too. It is also recommended, if you click on the videos tab, mathematics of finance, it is recommended that at least you have an idea of from 1 through 6 prior to annuities, the solved examples part 1. So in this video, we shall just use the calculator on the desktop, on your computer, so that you can see how it works, how you can use it to calculate these values, the future value of an ordinary annuity and the present value of an ordinary annuity. So we have already discussed all this. In this video, which will not take long, I shall show you how to use your calculator to do these calculations. Some of you still need help using the calculator to just compute this right away without having to go through all these steps. Now, I did all these steps to do the order of operations so that it will make sense to you. But some of you want to use your calculator and just know how to just get from here to here. So I'm going to show you how to do that in this video. I am also glad to introduce to you this calculator here, www.finance-calculators.appspot.com. So I encourage you to use this calculator to check your answers. If after solving the questions first, you can check your answer with this calculator and see whether we get the same answer. If we do not get the same answer, I encourage you to find out your mistake. I might be the one who made mistake, but first of all, try to preview yours again. Try to review yours again, and if you're very sure of your calculations and you think that the calculation here didn't give you the right answer, you feel free to contact me with this form. Okay? But before you do that, just review what you did. So we are going to look at the questions here. Let's start with number 1. We have discussed these formulas here in previous videos. We have done that. Actually, we discussed it in this video here. So this video, I want to just show you how to use the calculator on your desktop and also how you can check your answers with this web app. This is a financial math calculator, a web app that I designed. Okay. All right. So question 1, find the present value of a $170 per month ordinary annuity at 5% per year compounded monthly for 11 years. So I'm going to just pull up the calculator. This is Windows 10. So all you need to type is calculator here. And it says Trusted Windows Store App. You click on it. If you are not using Windows 10, then you might want to click on the Windows icon, or if you're using Windows 8.1, you get it from, when you go to the Edge, and you check for the accessories folder. You look for accessories folder, and you can get the calculator from there. That is if you're not using Windows 10. But if you're using Windows 10, you can just type in here on this Cortana. Just type in calculator and you get this one here. Usually when you pick this, it is in standard, If it is your first time opening it, it is in standard view. And you want to click here and put it in scientific view. So this is the formula right here. You know that it is compounded monthly, so M is 12. The periodic payment, in this case, the monthly payment is $170. The rate is 5%, which you want to convert to decimal. And the time is 11 years, so it is in years, so we are good. So you write it like this, so you know how to do it like this. The issue now is doing it step by step with the calculator to make sure you got it right. So I'm going to use a PEMDAS, order of operations to do this. First of all, I really want to get a single exponent. This is negative 12 times 11. So I want to first of all write 12 here and put this plus minus sign. Not the minus sign here, no. It is this plus minus sign that will give me the negative 12. And this is just for desktop and laptop calculators on Windows PC. The calculator on Mac might be different, okay? And some of the calculators that you have might be different. So with some calculators, you might want to type in this first. And some of them have, instead of the plus minus to give you this negative value, some of them have a parenthesis, then minus sign, and then close parenthesis to give you that minus value. So depending on the calculator you're using, okay, if you want to get a negative before the number, you either press the plus minus sign, or you press, if they have the one that has the parenthesis, then minus sign, then close parenthesis, okay, you press that one. And in some calculators, you might need to press that before you press the number. While in calculators like this one, you will need to press the number first before you press this. Please do not press this. No, this is what you press. You press 12 and you press the plus minus to get the negative sign in front of the number. Then you do times 11. And with this kind of calculator, you have to do equal to. Okay, so that gives us negative 132. So what I will do now is to save this in the memory. You might want to write negative 132 on your paper, but I want to be using the memory function on these calculators. So I'm going to press the memory function here. Now notice that right now these are not in bold. The MC is the clear memory, and the M arrow is the recall memory. Okay, memory recall and memory clear. So, but when I press M plus now to save it in the memory, so you see these two are now in bold to let you know that, hey, that something is in the memory function. If you're using a Windows 7 or Windows 8.1, this calculator might look different from what you're using, but the memory function in those ones still work. Okay, so I just write this and save it here, or you can write it down on your paper. Then the next thing I do is I can clear this now. I do 0.05 divided by 12 equal to. So it gave me this, and from what I have been explaining in the mathematics of finance videos is that you do not round intermediate calculations. You do not do that. You only round the final calculation. You do not round intermediate calculations because you don't want any rounding errors. Okay, remember that even 1 cent matters a lot in finite math, in mathematics of finance. Okay, even 1 cent matters a lot. So you want to avoid rounding errors. So I'm gonna use all these. Then I do plus 1 equal to. Okay, then this is in parentheses. I will now press x to the power y, x to exponent y. I raise it to negative 132. But rather than for me to type negative 132, I will get recall memory here, and I'll do equal to. So this gives me this. Okay, in the this is this here, this right here. So what I will do now is, let me save this in a new memory. So what I will do is I will clear the memory that is in there now, which is negative 132, and I will save this new value in a new memory. Okay, then I will now do 1 minus recall memory, and I'll do equal to. That gives me this. And I can just multiply by 12 and multiply by 170 and divide everything by 0.05. Okay, I can do that. Times 12 times 170 equal to. Then I divide by 0.05 equal to. So that gives me $17,233.53. Okay, so that is what that is the answer. Okay, let me do this again. So I will clear entries, and I will just clear this memory. And once I clear it, you see that it is no longer in bold. So the first thing I did was I got the negative 12 times 11 equal to. Okay, I save it in the memory. Then I did this parenthesis, 0.05 divided by 12 equal to. Then plus 1 equal to. Then exponent recall memory equal to. So I clear this memory now. I clear the memory initially, negative 132, and I save this now as a new memory. Then I will now do 1 minus recall memory equal to. And if you also want to divide by 0.05 before you multiply, that's fine. Divided by 0.05 equal to. Then times 12 times 170 equal to this. So you can practice it, to be more familiar with it. Okay, so this gives us the present value right here. And in using the web app that I designed, all you need to do, you click here, ordinary annuity / sinking fund / amortization. And in another video, we'll talk about amortization and sinking funds. In another video, we'll talk about this. But for this one, we are doing a present value of an ordinary annuity. Okay, so we want to find the present value, and that is this. This is what we're gonna use. So the periodic payment here is 170 per month. I put 170. It is compounded monthly for 11 years at 5% per year. So compounded monthly, the rate is 5%, and the time is 11 years. And that gives us the same thing here, the present value right here. Okay. The next one is finding the future value. And this is the formula we shall use here. So find the future value of a $300 per week ordinary annuity at 4.5% per year, compounded weekly for 8.5 years. So I'll pull up this calculator here. So let me clear entries and let me clear the memory. I'm gonna, in this case, you write out this. M is 52 because it's 52 times per year, which is weekly. The periodic payment, the weekly payment is $300, $300. The interest rate is 4.5%. You convert it to decimal. And the time is in years. If the time is not in years, you convert to years. But the nice thing about this calculator is, even if the time is not in years, you can select whatever it is. But for this, using your desktop, you have to make sure that the time is in years. So you write it out, you substitute these values in the formula, and then I'm going to, first of all, I want a single exponent. So I will do 52 times 8.5 equal to, I will save this in the memory, 442. Then I'm going to do 0.045 divided by 52 equal to, then I'll do plus 1 equal to, and then I'll raise this to exponent, recall memory, 442 equal to. Now if you want, you can write 442 on your paper and raise it to exponent 442. And then this is what it gives me, and I do minus 1 equal to. Then I can multiply times 52 times 300 equal to. And then I now divide by 0.045 equal to. So the future value of this annuity gives me $161,443, $161,443.50. Okay, that's a lot of money, right? So if you want me to do it again, I can do it again. I'll clear entries and I'll clear the memory. So I did 52 times 8.5 equal to, I save this in the memory. Then I do 0.045 divided by 52 equal to, then plus 1 equal to this, then exponent, recall memory equal to, then minus 1 equal to, then if you want to also do this division in this bracket, that's fine. It will give you the same thing. divided by 0.045 equal to this, then times 52 times 300 equal to this. Okay, 161,443.50. Make sure you put your unit. So right here, we will use this one, finding the future value. So the periodic payment in this case is $300 per week, compounded weekly, 4.5% interest rate per year, and 8.5 years. Okay, so this is $300 per week, compounded weekly at a 4.5%. Okay, and if you want to use decimal, then you have to use 0.045. Okay, and it will still give you the same thing. And the time is 8.5 years. 8.5 years. And this is the future value. Okay, if you have to use decimal here, then you change this to 0.045, and it still gives you the same thing. See that? But if you use 4.5, you have to make sure you select percent. Okay, go ahead and look at it, and you can also test these ones here. I think the rest of it has to do with what we've already done. So for compound interest for this question here, which is both compound interest and future value, for the compound interest, you use the compound interest calculator. We have already done this. I have already done this here for interest. I did it, and this is it here, where I showed my work with the calculator. All right, so the next one we'll do will be amortizations, and then the next one will be sinking funds. Okay, thank you so much for listening to this video, and you have a great evening.